All right, class. So here is page 5 of your Unit 6. We're going to look at rational expressions. So a rational expression has the form a over b. Basically, you should see fraction bar in all of our examples. And I'm going to teach you how do we simplify. Notice that we're not solving for anything, meaning we're not looking for that specific variable. We're just learning how to simplify. So whenever we have a rational expression, we usually simplify by, you might have heard it, where we reduce the fraction. Okay, so we can divide out or cancel common factors. Okay, so that's how we reduce radical, or sorry, I said radical, that's from Unit 5, rational expressions. All right, so let's look at the first problem here. So I'm going to do this the long way, and then hopefully we can kind of work it out where we can do it a little faster. But what I'm going to do with this 8 is I'm going to look at the 8 and I'm going to break it down into its prime factors. So basically, we know that 8, you can say that is 4 times 2. 2 is a prime number, but I can keep going with 4, that is 2 times 2. So basically, 2 times 2 times 2 is equal to 8. So I can rewrite it like that. And then x to the fourth is x times x times x times x. And then denominator, let's see what I can do with the 16. With the 16, that is broken down to 8 times 2. And then we know that 8 can be broken down to, like we just did here, 2 times 2 times 2. So you have 2 times 2 times 2 times 2, which gives you 16. And then you have 3 x's, 1, 2, 3. So when we are simplifying, we're going to cancel out common factors. So here, um, the 2 comes out, 2, 2, and I cannot cancel this because I don't have another one in the numerator, but I can cancel out an x, another x, another x. So what do I have left here? In the numerator, I have just one x left, and in the denominator, I have 1, 2 left, and that is my simplified version right there. Okay. This is a long way to do it. What we can generally do is we can just think about what is the greatest common factor between them. So we know that 30 and 5, this is just 30 divided by 5, which is equal to 6. And then I have one n in the numerator and four n's in the denominator, so I can take out at most 1 from the from here. So you just have, if I take out 1, I would have 3 left. So in the denominator, be careful. Over, so the 5 goes away because 30 divided by 5 is 6. And then denominator, I have n cubed. Over here, I'll keep the negative. So 3 and 21, 3 goes into 3 once, 3 goes into 21 7 times. And then there's 5 a's in the numerator and 7 a's. So I can only take out 5 a's, or 8, yeah. So that means I have a 7 minus 2. I'm sorry, 5 is 2. So in the numerator, I just have 1, and then denominator, I have 7a squared. Okay. Now this one, I'm not able to just, cancel stuff out because it's not, I can only cancel out common, let me go back up here. I can only cancel out common factors, meaning that something that's being multiplied to the whole thing, something that's being multiplied to this whole thing over here. So what I have to do first before I can do this is do, um, I need to factor I need to factor each, or sorry, factor numerator and denominator separately first. Factor numerator and denominator to find common factor. Okay, and this is what it looks like. So if in the numerator here, I can go ahead and factor out a 3 because 3 goes into 3 once and 3 goes into 15 5 times. So I can factor out a 3. So because 3 times x is 3x, and then 3 times negative 5 is negative 15. And then in the denominator, I'm going to factor out a 2. So 2 goes into 2 once, and 2 goes into 10 5 times. So 2. So you have 2, and then negative 10 divided by 2 is negative 5. Now you can clearly see that there's a common factor here. This whole thing is one thing that's being multiplied. So I can go ahead and cancel out that whole thing right there. And then so you have here 3 over 2. Okay, so this one's a little tricky. There's really nothing I can factor out in the numerator, but because it's already just everything is already just being multiplied, I can't like tear it apart more. So I'm going to bring that down. And then in the denominator, I can factor out 10 goes into 10 once, 10 goes into 44 times. I can do 10. And then also there's an n and an n, so I can take out an n as well. So here, if I divide n squared, so if I have this divided by this, because when I'm factoring out, remember I'm dividing, so this gets crossed out, so n squared divided by n is just n, okay? Plus, if I take, this is a 4, so 40 divided by 10 is 4. All right, so now what I have here is I do find a common factor now. I see that there's a 10n in the numerator, 10n in the denominator. I can cancel those out. So in the numerator, I just have 1, and then you have n plus 4 here. Okay, number 6, we see that we have x squared plus 13x plus 42. And then over x plus 7. So for this one, we're going to have to do the other type of factor where we factor trinomials. So the only way I can factor trinomials is by doing this. So like I'm going to put x times x, and then you have, excuse me, 42. So we have to think of two numbers that multiply together that give you 42, but when you add them together, they give you the 13. So that would be what? 7 times 6, because 7 times 6 is 42. 7 plus 6 is 13. That works. And then you have x plus 7. Now, you notice that there's a factor, x plus 7 in the numerator, x plus 7. I can now cancel those out. And then you have x plus 6. That is my final answer. That's my simplified version. Now, we want to be able to check if our answers are correct, and you can check those in Desmos. So let me pause for a second from doing the rest of the problems, and let me give you a way that you can check your answers in Desmos. So I'm going to go to Desmos. I'm going to look at the first one. So what I generally do is I'm going to go ahead and put my question right here. I'm going to put it in my Desmos, so 8x to the fourth over 16x to the third, oops, over 16x to the third. And then what it does, Desmos, is it graphs it for me. It gives me this graph. That's fine because my answer should match the graph because I'm just simplifying it. I'm not changing anything. I'm just simplifying it. So they should be equivalent. There you go. It happened so fast you probably didn't even see it. So here's my first graph in the blue. Here's my second graph in the green. They're the same exact graph, so that's how I can check my work. Let me check number 2. So you have here 30 n. Actually, let me go ahead and put my fraction bar first, which is just a division symbol. So that's 30n over 5n to the fourth. And then now notice that it's not graphing anything because it only graphs it if you put it in with the x or x and a y. Okay. So since I have an n, it's expecting me to plug in a number. Well, what number am I going to plug in? And the way you plug in a number, you can plug in any number really. So I'm just going to press this. It automatically plugs in 1, and you can just kind of change this. Don't put a negative, just put some positive number here. So like 5.7. Okay. And now my answer should match this decimal right here. So I'm going to put 6 over n to the power of 3 and see how it matches exactly. So I know I did these right. Let me check this one. So that is a 3, I can't even read that, 3a, there's a negative, there's a division symbol, um, a to the fifth, sorry, I gotta erase this. Yeah, that's a 5 to the fifth over 21a to the seventh. And it's asking me to plug in a number. No problem. I'm just gonna plug some random number in here. I told you not to plug in a negative and I didn't. It's just my answer is coming out to be negative because of the negative. So then my answer that I have is negative 1 over 7a squared. See, it's the exact same answer. Even if you change it, they end up being the same. So that's how I know I did this correctly. I'm not gonna check the rest of them, but well, let me just check one. Maybe I'm not too sure about this one. Let me check it. Notice that it just has a lowercase x, which is fine. I'm gonna go ahead and just plug it in, and I can just check it with the graph, right? 13x plus 42 over x plus 7. And there's my graph. And then let me graph my answer, which is x plus 6. There you go. I don't know what all those points were, but there you go. They're the same exact graphs. I know that this expression is correct. All right, so now let's go ahead and do the rest of these problems. Again, we're just, well, no, on this one, we're not. This first one we were simplifying, so we needed to reduce. The second one is multiplying expressions. So it helps to simplify first before you multiply, okay? And then you can multiply. So when you're multiplying rational expressions, here's the general form. So if you have a rational expression a over b times another rational expression c over d, let's say, then you just multiply the numerators. So in the numerator you have a times c, and in the denominator you have b times d, okay? So technically here you would just do 8x times 6 times 3 times 8, and then you can simplify, or you can simplify first, and then you can, so you can just multiply. So I'm going to show you both ways. Here's the first way. I'm just multiply straight across. So 8 times 6 is 48. And then you have your x. And then 3 times 8 is 24. And then we need to be able to reduce it. So 48 over 24, um, I guess 8 goes into both of it. 8 goes into 48 um, 6 times. 8 goes into 24 3 times. So you have 6x over 3. So you can do it that way. Or you can just first reduce. You can first reduce. Okay, so either way you're going to reduce. So you can cancel out the 8s first, and then you can cancel out a 3, and then this becomes a 2. 3 goes into 3 once, 3 goes into 2 twice. So in the numerator, you have 2 times x, which is, sorry, wait, what did I do wrong here? Oh, I see what I did wrong. Okay, let me finish this problem. So 2 times x is 2x over, um, that's it. I just have 2x. Well, how come I didn't get 2x here? Because I just need to finish reducing this. So you have 6 divided by 3, which is 2, and then you have your x. See? It's the same thing. All right, so for this one, I'm not going to multiply these out first because that's a lot of like the FOIL method, you know. I'm not going to do all that. I will go ahead and simplify first. So to simplify, we're going to cancel out the common factors. So in the numerator, I have p plus 5. I don't have a p plus 5 in the denominator. I have p minus 6. I do have a p minus 6. I have p plus 10, p plus 10. So that works. So you have p plus 5 in the numerator over p minus 1. And then here, some students want to just cancel out the p's, but I cannot cancel out a p because it's not a factor. It's not being multiplied to the 5. There's an addition symbol, so I cannot just cancel it out. I have to leave it like this. This is my final answer. Okay, so this one you have, I can cancel these two out. I can cancel these two out. So you have, and then 5 goes into 5 once, 5 goes into 24 times. So in the numerator, I have 1, and the denominator, I have 4, and that's my answer. If you want to, if you're like, I don't know if that's right, you can always go ahead and, plug it in. You can do, so you can do 5 over m, whoops, what is that? M minus 2 times division symbol m minus 2 times m plus 8 over 20 times m plus 8. Add a slider. You can add any number you want, and it's still just going to give you 0.5 because 1.1 over 4 is 0.5. Okay, so it's definitely correct. All right, let me finish these last 3 problems. So I can take out the 20a squared. I can take out this a plus 1 together because it's being multiplied. And then so what I have left here is 6 over a plus 4. Over here, I need to first factor out the numerator here. So you have x minus 3. And then you have here, I'm going to go ahead and factor this trinomial. We were doing this in Unit 2. So we need numbers that multiply together that give me 18, but then you add together give me negative 9. So these both have to be negative, so that would be 6 times 3. 6 times 3 is 18. Negative 6 times negative 3 is positive 18. Negative 6 plus negative 3 is negative 9. That works. Then you have x minus 6. Alright, so now I can go ahead and cross these out, and all I have left here is a 1. Okay, we we can go ahead and check it. It's easy to just check it. Now, if you're like, can I just do that from the beginning? You can, but sometimes they don't just come out all nice and neat like it did here. X minus 3 times um, x squared minus 9x plus 18 over x minus 6. And now it's giving me a graph here. Well, how do I know that this is the right number, that it's equal to 1? Well, it notice that it puts this line right here at 1. Okay? If you want to, you can, I mean, that's kind of a hard way to see this. Sometimes what I do is I can just change it from instead of, I like to just plug in a number. So like I can go back and just change it to something that so that I can be, and instead of graphing it, I can just plug in a number. Look, I can plug in any number and it keeps giving me 1. Okay, so that's my answer. All right, last question. We need to first go ahead and simplify, factor this out. So, um, plus, minus, so you can do 6 times 1 because 1 plus negative 6 is negative 5. And then you have x plus 1 times 1 over x plus 6. So these two get crossed out. These two get crossed out and you just equal to 1. And I won't check it. That's fine. Okay.